Good morning, this is your stat sensei, Mr. Spensei, and this is a warm-up on two sample t-tests, and it's an introduction. So here we go. First off, I want to say that two sample t is much like a one sample t, but the formula is substantially different. One sample t, our formula is going to look like this. T equals x bar minus mu s divided by square root of n. So you can see that we've changed things up a bit. All right. Now, technically, the numerator is t equals x bar 1 minus x bar 2 minus mu 1 minus mu 2. But we're going to find out later that this part is assumed to be 0, so we drop it off. So here it is, smokers. San Antonio has more than 90,000 adults who smoke cigarettes and approximately 1.5 million who do not. The UT Health Science Center of San Antonio took a random sample of 36 smokers. So, okay, we have a list of smokers and we know that there's 36 of them from the random sample. And they do say random sample, which is going to be important. With a mean resting pulse rate of 85. So the mean resting pulse rate of 85 beats per minute and a standard deviation of 17 beats per minute. A separate random sample of 32. All right, random sample of 32. Non-smokers had a mean of 77 beats per minute and a standard deviation of 11 beats per minute. Beats per minute. Test an appropriate hypothesis at a 5% level. We're not going to do the testing right now. And matter of fact, I know the directions say do not plug, but I'm going to go ahead and violate my own directions and plug in. So we have T equals X bar 1. And it really doesn't matter which one you choose to be X bar 1, just be consistent and make sure it matches your hypothesis. And then we're going to have 17 squared over 36 plus 11 squared over 32. All right. So parameter for smokers. So let mu1 equal, or you can put mu s if that helps. Mu1 equal the true population mean. Well, what do we care about? Resting pulse rate. And we need to distinguish who it is for smokers. All right. Mu2, our second list was non-smokers, and it's going to be almost exactly the same thing. Let mu2 equal the true population mean resting pulse rate for whom? For non-smokers. All right, because it's two samples, we get to do the conditions twice. Well, the first condition is always random sample or random assignment if it's an experiment. And random sample of we 36, they told us the random sample of 36, and that was given. Here we have, they also told us the random sample, but for the non-smokers, it was a sample of size 32. So random sample of 32, and that was also given. All right. The next thing we need to do is check the N is less than 10% condition. Well, we know that 2 N equals 36 times 10, which equals 360. And what did they say we had? How many smokers? 90,000 adults. Well, 360 is less than 90,000. All right. So now we're going to make this the statement N is less than 10% of the population. I'm going to abbreviate that because I ran out of room. And lastly, we need to address normality. Well, in this case, our sample size is 36. So N equals 36, which is greater than 30. The distribution of means is approximately normal by central limit theorem. Please remember, there are three ways to check normality. One, they told us it was normal. Two, our sample size is larger than 30. Or they gave us data and we graphed the box plot and checked to see that it's normal that way. Number two, on this side, we need to check the N is less than 10%. We have 32. And these are the non-smokers. 32 times 10 equals 320, which is less than, well, up here, they told us we had 1.5 million. 320 is definitely less than 1.5 million. N is less than 10% of the population. And by the way, I'm going to make this N1 here. All right. And over here, I'm going to make it N2. N2 is less than 10% of the pop. All right. Number three, normality. Well, in this case, we had a sample size of 32. So N equals 32. That's greater than 30. The distribution of means is approximately normal by central limit theorem. All right. Appreciate you watching. Hope that helps. Look forward to seeing you on the next one. Thank you.